Hello, this is Sadashiv Fadnis, Product Marketing Manager for Rubidium signal generators here at Anritsu. In this video, I'll be explaining various trigger mechanisms available in Rubidium's pulse train option. If you would like to learn more about Rubidium's pulse train option itself, please look at video titled Generating Pulse Train, option 25, published previously. Wide variety of trigger mechanisms available in Rubidium's pulse train option enable users to generate long periodic and non-periodic pulse patterns. Such pulse patterns are very useful for many measurement applications, including testing radar warning receivers. This video has 4 parts. Part 1 explains the setup and the free running trigger mode. The second part explains single step and single sweep trigger modes. Part 3 explains breakpoint and multiple sweep trigger modes. Part 4, the concluding part, explains various trigger sources and how to combine them with trigger modes to generate periodic and non-periodic pulse patterns. Okay, so the next trigger mechanism we are going to explore is the multiple sweep. So before I choose that, again let me go back and disable the pulse train. Come back to the trigger menu and let's choose multiple sweep. So what does this multiple sweep trigger mode do? In order to explain that, let me go to the setup screen first. Now there is an entry called repetition here. This entry defines the number of times all the pulse bursts are output. So when you choose multiple sweep trigger mode and you enter however number of repetitions in this column, in this entry, let's say 3, let's say I enter 3, then the signal generator is going to generate 3 sweeps or 3 times all the pulse bursts and stop. So let me show you what it looks like, and before we go that, let's say I enable the pulse train, and then I've chosen multiple sweep, and remember we have chosen the repetition factor as 3. So let's come back and trigger it, right? So you see this, the 3 50% duty cycle, the 11 narrow and the 3 broad. So this whole pattern will be repeated 3 times, and here we are not able to capture all 3 because our sweep time is a lot smaller. So let me go back and let me increase this sweep time to 10 milliseconds. I think that should be large enough to look at all 3, and then let me close this, and I'm going to trigger it again so that we can capture it, and there you go. So with this mechanism, with this multiple sweep, we defined sweep as 3, so it's outputting all the 3 bursts 3 times, right? So this is 1 time, this is the 2nd time, and this is the 3rd time, and we can choose that repetition to 2, for example, and let me choose it as 2, and then you come back and then you trigger again. It's going to output only 2 times, right? This whole pulse pattern repeated twice. So you can control the number of times this entire pattern is repeated using this repetition factor, and the max on this repetition factor is 10. Right, so you can define any number up to 10, and then the signal generator will output the pulse pattern defined by these 3 bursts, 10 times or whatever number you define in that setting. So we have looked at various trigger modes. Now let's look at different trigger sources. So far, as you have seen, we have used a single source while exploring all other trigger modes, these free running, single and single sweep. Now let's look at other sources. So there are four sources. Single, which we have used previously, then there is external gate, and timer. The external and external gate are both hardware triggers which are external to signal generator. Single is internal trigger source. So you can input external triggers into a BNC input on the back panel of Rubidium, and choose it as trigger source. So the external could be external or external gate, and whatever you were able to do in different trigger modes using the single source, you can do with external and external gate as well. Meaning, when you choose external and external gate, the behavior of these trigger modes is going to be the same as when you choose single. The only difference is single is an internal trigger and external gates are external triggers. Okay, so now let's look at the last one, which is called the timer, trigger source. So let's look at what it does. Now there is a setting associated with this timer trigger source, which is called timer value, and you should enter a value, any value that is greater than the PRI of the pulse train, PRI period of the pulse train. For example, in this case, the PRI period is 28. What I have entered here is 2890 microseconds. You can enter a number bigger than 2890 microseconds, and I have entered 5000 microseconds here. This timer trigger source is applicable to two of the trigger modes, the single step or the single sweep. It's not very meaningful for breakpoint or multiple sweep modes. So let's choose the first one, which is single step, right? Okay, so and then let me go back and check whether the pulse train is on, just to make sure. I'll put it off and on again and go back to trigger. So we have chosen single step, timer mode, timer value 5000 microseconds, and now the signal generator is outputting the pulse train using this timer as trigger source, and we are in trigger mode. Okay, so let's look at what is happening on the spectrum analyzer after we chose the trigger mode as single step and trigger source as timer. And what I've done here is I have deselected the continuous mode because we are going to trigger the sweep, the spectrum analyzer sweep, one by one. So because we want to see what happens with this timer source. So let's trigger once. So what this timer does is, it's basically the single step mode is the mode where signal generator will output one burst at a time, right? So in this case, you can see it is outputting one burst at a time. This is the last burst and this is the first burst, right? It is outputting this, but instead of outputting it continuously, it is inserting a time gap Now, what is that time gap? The time gap is because of the source, the timer source that we have chosen. And let me move this marker to the beginning of the next burst, right? So this is the third burst, and then this is the next burst. This is one burst, and this is the next burst. And 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 the delta between these two is 5000 microseconds, which is what we have entered here. So the timer mode essentially waits for 5000 microseconds before initiating the next burst, right? After it initiates the first burst, then it waits for 5000 microseconds before initiating the next burst. Let's trigger it again and see what happens, right? Once again, okay, so this is the second burst and this is the third burst, you see. And then as soon as it initiates the second burst, and let me go back to the list and see, right? So this is your second burst. So it initiated the second burst, meaning it started outputting the second burst, and then before it starts outputting the third burst, it's going to wait for 5000 microseconds, right? And you can see that happening again with this, the first and the second here, right? The first burst is the 50% duty cycle, so it initiated the first burst and then wait for 5000 microseconds before it initiates the second burst, right? So this is what the timer does in the single step mode. So it essentially inserts a delay of 5000 microseconds after the first burst is initiated, and then another 5000 after the second burst is initiated, and so on. Now if you choose this, instead of single step, if you choose single sweep mode, it does essentially the same thing, but now the signal generator is going to initiate the first sweep, and then it is going to wait for 5000 microseconds before it will initiate the next sweep. So let's look at this now. Let's recapture here on the spectrum analyzer, and here you go, right? So it started the first sweep, which is essentially let's go back to the list. So the first sweep is all these three bursts in one go, all these three bursts in one go, and then wait for 5000. Once you initiate this, wait for 5000 microseconds and then initiate the next burst. And once you initiate the second burst, then again wait for 5000 microseconds. And you could see that if I increase my sweep time to 15 milliseconds, you could see another burst, right? So start of the first burst, wait for 5000, start of the first sweep of all the three bursts, right? And wait for 5000 milliseconds before you start the second sweep of all the three bursts, and then on and on and on, right? This keeps on doing that, right? So this is what fundamentally the timer source does. So just to summarize, the timer source is used to insert a delay from beginning of the pulse burst or pulse sweep to the beginning of the next pulse burst or pulse sweep. That's what the trigger source does. With 5 trigger modes discussed, Rubidium provides unprecedented flexibility in generating pulse patterns, both periodic and non-periodic. This flexibility is unique to Rubidium and is very useful for testing radar receivers.